Yes, so in last lecture we had discussed center of the group, and we have seen some properties of the center, and also we had discussed center of various groups, especially GLNR, SLNR, and then Q8, and of course center of any abelian group is itself. So there is no need to discuss specially for the center of abelian group because it is trivial, right? You consider any abelian group, then its center is group itself. But in the case of non-abelian group, center of the group will not be whole group. Definitely it will be some subset of the group, and in fact it is going to be normal subgroup of the group. Okay, so now in this lecture, let us introduce one new group, dihedral group, and that is a very important class of the group. It is a non-abelian group, so it will be helpful for counter examples. Also there are so many questions asked in the exam based on the dihedral group. So what is this dihedral group? Basically it is attached with geometry also. So let us start with the origin of the dihedral group. Okay, how we construct that group from the geometry. But we will deal with this group by separating the geometry, right? इसमें जो ज्योमेट्री का पोर्शन है वो निकाल देंगे, क्योंकि वो ज्योमेट्री से हैंडल करने के लिए यू नीड सो मेनी फिगर्स एंड ऑल थिंग्स, बट वी विल डील इट abstractly, right? But we will see what do you mean by deal with geometry and deal with abstractly. Okay, so dihedral group. Dihedral group. So this is a group of symmetry of n-gon, regular n-gon. So let me start with a square. We start with a square. You consider one square. So say this is my square, and let me give the name. This is A, B, C, and D. See, this is a square, so all the four sides are equal and all these angles are 90 degree, right? Okay. Now what I will do, I will rotate this square. See, you imagine like this. This is my x-axis, this is my y-axis, and you put this square so that origin is what? It is the intersection point of its diagonal. So center of the square is at origin. So I have this situation. See, A, B, C, and D. Now what I will do, you rotate this square by 90 degree, right? You rotate this square by 90 degree. So see, this is a diagonal, so definitely this angle will be what? This angle will be 45, and this angle will be also 45. Sorry, not this one, this diagonal, so this also 45. So if you rotate this angle, this square by 90 degree, then 45 plus 45, so it will be 90. So this B will comes at the position of C. By the same thing, C will comes at the position of D. D will comes at the position of A, and A will goes to the position of B. So if I give 90 degree rotation, then what I get? I have this situation of this square, and it is what? A, B, C, and D. Okay, so this is my what? This is my starting position. So I will give this position or this square name by R0. Now what I did, I gave 90 degree rotation in anti-clockwise direction. See, here I am fixing the direction also. I am rotating the square in anti-clockwise direction. then I obtain this position or this new square. But see, if I remove the name of the vertices, then you will see there is nothing difference between that two things. You can see here, you just rotate 90 degree and you just remove the vertices, then you will see it is the same. But actually I gave the rotation of 90 degrees, so that two objects are previous one and obtained objects are different. So that's why we know it is a symmetry. Symmetry means if you change somehow, then you will get the same thing. That is called symmetry. So I will give this position by R90. R90 means it is a position obtained from R0 by rotating 90 degree, right? Okay. Now again you rotate this by 90 degree in anti-clockwise direction, then I have this situation. And it is what? It will be A will goes at the place of B, B will goes at the place of C. So this will be what? This will be B, this will be C, and this will be D. So I will give this position, I will not denote this position by R180. You can see 90 plus 90 is 180, or you give the 2 times 90 degree rotation, that is 180 degree rotation on R0, then you will get R180. Now again you give the 90 degree rotation in anti-clockwise direction of this position, then this A will occupy the position of B, B will occupy the position of C, C will occupy the position of D, and so this is C, and D will occupy the position of A. So let me say this is R270. 180 plus 90 is 270. And you give the anti-clockwise 90 degree rotation to R270, then A will occupy the position of B, so this B will occupy the position of C, C will occupy the position of D, and D will occupy the position of A. So I get the same R0 back, right? So this is what, so I have 4 positions, R0, R90, R180, R270 obtained by 90 degree rotation in anti-clockwise direction starting with R0. Then I reach at R0 in this manner. So these 4 objects, 4 positions are symmetry of the square. I will say it is a symmetry of the square, and that symmetries are obtained by rotation. Okay, now let me consider, this is my R0, right? A, B, C and D. Now let me consider a horizontal line passing through the center of the square, and you just flip it. You just you have this square, so you just flip with respect to this horizontal line. So I am taking the reflection. So A will occupy the position of D, and D will occupy the position of A. Similarly, B will occupy the position of C, C will occupy the position of B. So what I have? I have this thing, D, C and A, B. So this position is obtained from R0 by taking the reflection with respect to horizontal line. So H stands for horizontal. So let me denote this position by H. So again, if I remove the name of the vertices, then these two objects will look like same. So again, this is a symmetry. Now you can have this thing also, A, B, C, D, and you consider a vertical line passing through the center of the square, and you take the reflection with respect to this vertical line. Then what I have here, B, A, and here C, D. So it is a vertical reflection about the vertical line. So I will say this position by V. Now again you consider this one, A, B, C and D. So you consider this diagonal, and you just take the reflection with respect to this diagonal. Then A and C will interchange, but B and D will remains as it is. So I have this situation. This will be C, this will be A, this will be D, and this will be B. So this is a diagonal line. So let me say it is D. So you don't confuse with this D and this D. This D is a reflection about this diagonal line, right? Okay, fine. Yes, and this D is a vertex D. Now you consider one more. So this is A, B, C, and D. You consider this diagonal. Then you have this B and D will interchange. So B will be here, D will be here, A and C. So if I say this diagonal by D, then let me say this diagonal is D dash. So this position is said D dash. So what I have, I have this 8 symmetries. I have 8 symmetries. And how 8? 1, 2, 3, 4, 5, 6, 7, 8. Right? So here I am giving the rotation. Here I am considering the reflection about horizontal axis, about vertical axis, about 2 diagonals. Okay. So what is my object? You consider the set of, let me consider a set. You consider this set R0, R90, R180, R270, H, V, D and D dash. Let me write here, it is H, V, D and D dash. So this first for our rotations. So I have used R stands for rotation, and these 4 things are reflections about horizontal axis, vertical axis, diagonal and secondary diagonal. So what is this? So these are position of square, and all these are what? Symmetry. So now I want, so now I have this is set. This is a set which contains the position of square. Now I want to make this set to be a group. So for that what we need? G is a non-empty set, and I need one binary operation. So what do you mean by operation here? Okay, तो हम इस पर एक ऑपरेशन डिफाइन करेंगे. ऑपरेशन मतलब क्या? फॉर एग्जाम्पल सपोज आई वांट टू फाइंड दिस R180 इंटू H. ये दोनों एलिमेंट है मेरे सेट के, तो इसका प्रोडक्ट क्या है? तो इट मीन्स व्हाट? यू स्टार्ट विथ H. You start with H, right? What is your H? H is this position. This is your H, right? It is DCBA. Now R180. Now you apply this operation on this. So how I get this operation? So this operation or this position is obtained by taking 180-degree rotation in anti-clockwise direction of the R0. So I am applying R180 on H. It means what? You take the 180-degree rotation in anti-clockwise direction on the position H. तो ये मेरी H position है, तो इसमें 180-degree rotation ले लो. So by giving 180-degree rotation, so what I get? If I take 90-degree rotation, then A will move to D. But if I take another 90-degree rotation, then it will moves at the position of C. So A will become C, right? D will becomes B. 90, 180. So D will be here, right? Sorry, here I have A, then D. B will moves at D. and remaining is what? C. So C will move at B and A. So here I have. So what is this position? A, B, C, D. So where it is? A, B, C, D. Here you can see A, B, C, D. So this is what? This is my position V. So if I give 180 degree rotation on H, then I will get V. So product of these two is V. So similarly, you can find product of any two elements here. See, let us evaluate one more. Let me consider HR180. HR180. See, just I am taking its reverse. R180H and here HR180. So I have to start with R180. You start with the position R180. What is R180? It is A, B, C, D. A, B, C, D. Now what I am applying? H. So H means what? It is horizontal reflection. So you consider a horizontal axis or horizontal line, and now you take the reflection about this line. So here C, here B, then here D, and here A. So now you will find out which position is this. So it is A, B, C, D. A, B, C, D. So again it is C, V. It is what? Again it is V. So again it is V. So this is just coincidence. R180H and HR180 both are in V. Sorry, both are V. So these two commutes. But it is not necessary that any two elements of these two will commute. Okay, now let us consider one more. Let us find just HD. So what is HD? So you start with position D. So D is what? A, B, C, D. A, B, C, D. This is my D. Now you apply H. Horizontal reflection. So you consider a horizontal line and you just take the reflection. So this will be C, this will be D, this will be B, and this will be A. So A, B, C, D. So A, B, C, D is what? A, B, C, D. So this is what? It is R90. So this will be what? R90. So see, in this way you can compute product of any two element. So it is just composition of function, right? Every member can be considered as a function and you are just applying composition of function. So to find out product, so let us prepare its scalar table, right? So so I think you know how to compute this. Suppose I have given three things. Say somebody asks what is H, R90, D dash, then R180. So what do you mean by this? You start with R180 position, then you apply the action, obtain how we obtain D dash. So you just take the reflection about the secondary diagonal, then you have one position, then on that position you give the 90 degree rotation in anti-clockwise direction, and then you take the horizontal reflection. So you will get one of the position, so that will be its answer, right? But how to compute this? To do this, I need all these figures, etc. And our object is what? To remove these figures. So this is what geometrical approach. But at every time it is not possible to draw these figures, right? So we try to remove this process to obtain this thing, right? So we'll see how we can remove it. So first of all, let me prepare the composition table or scalar table for this set. R0, R90, R180, R270, H, V, D, dash. R0, R90, R180, R270, H, V, D, D dash. See, now if you apply R0 on any, say, see, R0, R90. So R90, you start with R90 position, this, and R0 means your starting position. There is nothing. You are not doing anything on this R0. This is your starting position. So if you apply R0 on any element, then there is no change, right? So it means what? It will work as identity element, or you can say you give the 0 degree rotation. R0, 0 stands for 0 degree rotation, 90 means 90 degree rotation. So if you have any object, here we have square, so you give the 0 degree rotation to this square, then it will be as it is, right? So R0 is R0, this will be R90, R180, R270, H, V, D, D dash. Correct? Now R0, R90, R0. So you start with R0 and you give the R90 90 degree rotation, then you will get R90. Similarly, here you will get R180. You can verify this, R90 into R180, R90 into R180 is R270. It is just addition. 90 plus 180 is 270. You start with 180 position and give the 90 degree rotation, then you will get 270 position. So this will be R270. So similarly, this will be R0. Now, okay, let me complete this box first. R180 plus R80 into is R180. This will be R270. This will be R0 and this will be R90. Okay, so this will be R270, R0, R90, R180. Now this portion will be D dash D V D dash D HV, sorry, D dash R90 into H will be D dash, R90 into V. You have to calculate first, you have to calculate like this, then you can fill this. So it is D dash D H V, then this will be VH, these two will here VH, and see here what I get, HV, these two elements here. So here I get these two elements, D dash and D here, and D dash in reverse position. So here VH. So this is just to remember, but we will not going to remember this. It is just for understanding this idea. Okay. Now again, here we have D dash. D dash D. So here D dash. D dash, and here we have VH. These two things here as it is, right? So to compute this block, what you do, you start with HVD dash because it is R0 identity, so it will be as it is. Now you take last two positions as it is here. You shift last two positions as here, and here you just take the reverse. HV. Yes, it is HV as it is. These two here and these two here. Now HV. Okay, last two but in reverse order, D dash D, and these two as it is. Now these two as it is, D dash D as it is, and here I have VH in reverse order. Now D dash D, D dash and VH as it is. So you have that block. Now let us compute this thing. So here what I get, here R0, you apply H on R0. So H on R0, H on R0 will be H. H on R0, you start with R0 and apply H, so you will get H. So similarly this will be H, V, D and D dash. Now this column will be D, D dash, VH. This column will be VH, D dash, D and D dash, D, H, V, right? So what is the pattern here? Here H, V, you can see here D, D dash. So these two will appear here and these two will appear here, but in reverse order, VH. Now these two will appear here and these two appear here in reverse order. These two will appear here and these two will appear here in reverse order. So this block is complete. Now about this block. So this will be R0, R180, R90 and R270. This will be R180, R0 and R270, R90. This will be R90, this will be R270, R0 and remaining is R180, and this will be R270, this will be R90, this will be R180 and this is R0. So what is here in this block? What is the pattern? Diagonal is R0 and it is a symmetric. See, R180, R180, R90, R90, R270, 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 R270 and R180, R180. So that is a symmetric block as a symmetric matrix, right? So this is what computation table of this set. Okay, so now if you compute, if you want to compute this any arbitrary expression, say R180 into H D dash R270 D dash V. Suppose I want to compute this expression, then what I have to do? So see, it is what? It is this thing. First I will start with V D dash. So V and here D dash. So V D dash is what? V D dash is R90. So this expression becomes R90 R270 D dash H R180. Now R180 H D dash R270 90. So R270 R90 is R0. So this is what? R0. So now R180 H D dash R0. So R0. See here you can see R0 is what? It will work as identity element. So D dash R0, and you can verify also D dash R0 is D dash. So this is D dash. Now D dash H, right? So you start with H and D dash. So it is R270. Now R180 270, R180 R270, it is R90. So this one is what? It is this one. So one way is what? One way is you just draw the figure and apply in this geometrical way. And the another way is what? If you have this table, then you can find this easily. Okay, but this table is also difficult to compute, or it is actually it is not difficult, but it is time taking process, right, to compute this thing. Okay, so now what I want to do here is this one. See, so now I just remove these figures, right, because I want to do the calculations without figure. Our object is what? to do the calculation without object. Okay, first of all, let us verify first this set is a group actually. So for that group, what we need, first property is closure property, right? So if you take any two elements, then its product means composition, whatever we define, it should be again in this set. So here you can see the any product of any two element is available here, and all these objects are again here. So first property is satisfied. Now second is what? Associativity. So actually you are giving the rotation, reflection, etc. So these are what they are, one kind of functions, and composition of function, whenever it is defined, it is associative. So if you consider any three objects and you operate, first you operate last two then with first, or first two then with last, then you will get the same thing, right? So it will be, obviously it is associative. Now identity element. So R0 is identity element. Here identity is what? R0. And what about inverse? So you just look at the identity in every row. Right? So identity R0 inverse is R0. R90 inverse. R90 inverse is R270. So obviously R270 inverse is R90. R180 inverse is itself. See, R180 inverse is R180. Now H inverse is H. You can see H. V inverse is V. D inverse is D. And D dash inverse is D dash. So this H, V, D dash are self inverse. And R0 is identity, so its R0 inverse is R0. R90 inverse is R270, and R180 inverse is self inverse. So I have here, see, 1, 2, 3, 4 and 5. 5 elements is self inverse. So the elements except identity which are self inverse, identity, of course identity is also self inverse, but I am interested the elements which are different from identity and self inverse, they have order 2. So I have 5 elements of order 2, 1, 2, 3, 4 and 5. तो ये जो elements है मेरे, इसके order हो गए 2. ये identity, इसका order 1. बाकी बचे ये, sorry, this is not R180, right? इसका order 2. बाकी बचे R90, R270. So the order of R90 is what? See, R90. So R90 square means R90 2 times 90 degree rotation. So it will be R180. R90 cube 3 times 90 degree rotation, R270. R90 raised to 4 times 90 degree rotation, you will get the same position, that is R0. Right? So order of R90 is 4. So R90 का order 4 है, तो R90 के inverse का order, so the order of element and order of its inverse are always same. So order of R90 and order of R270 are 4. So if I just list R0, R90, R180, R270, H, V, D and D dash, तो इन सब का ऑर्डर 2 है, इसका ऑर्डर 1, R90 ऑर्डर इज 4, R180 ऑर्डर 4, सॉरी R180 ऑर्डर 2 एंड R270 ऑर्डर 4. तो ये जो मेरा ग्रुप है, ये पहले तो ग्रुप बन गया, क्योंकि हर एक एलिमेंट का इन्वर्स मिल रहा है, आइडेंटिटी है, इन्वर्स मिल रहा है, और इट इज़ क्लोज्ड अंडर द ऑपरेशन एंड इट इज़ एसोसिएटिव, सो इट इज़ अ ग्रुप. So let me give the name to this group. I will give the name, it is D4. Why 4? I have used because it is obtained on the symmetry of a square, and square it is what? It is a 4 regular gone. Right? It has 4 sides or 4 vertices, you can say. So I will use the notation D4. तो ये D4 में एलिमेंट्स कितने हैं, ऑर्डर ऑफ D4 इट इज 8, 4 रोटेशन 4 reflections, so 8 elements, so 8 is what, it is 2 into 4, so order of D4 is 8, and we know the order of every element of D4 also. So D4 has 5 elements of order 2, 2 elements of order 4 and 1 element of order 1. So this is the structure of D4. Among these 8 elements, 4 are reflection and 4 are rotations. These are 4 rotations and these 4 are reflections. Okay, now let us see one more thing. तो हमने ये D4 कैसे कलेक्ट किया था, ये मैंने I have started with a square and then I have give its a 90-degree rotation, then I have this 4 object, then I give the reflection about horizontal axis, vertical axis, diagonal and secondary diagonal, then I got these 4 elements. Okay. Now what I do, here these 4 are called rotations and these 4 are called reflections. Now what you take, you consider one rotation and one reflection. So see, you take x is equal to h, so this is my reflection, and you take y is equal to say r90, so this is my rotation, correct? Okay, so now what is my object? I will do something with this h and r90 and I will obtain all this element, right? So what we do, see you consider this set. So let me write in this way, h and r90 like this. So you don't go with this note, don't bother about this notation. I am starting with h and r90 and I am considering this. See, h is what, now we know D4 is a group, so h is element of group, and we know that 0 power of any element in group is identity, right? If G is a group and if I consider A belongs to G, then A raised to 0 is identity, and A square means what, A 2 times whatever the operation here. So here what do you mean by h cube, what does it mean? So h is an element of D4, so h cube means what, it is h. You start with the position h, give the horizontal reflection, whatever you get, again give the horizontal reflection. Okay, so like that. Similarly we have for other elements. So what I will consider, see, you start with h raised to 0 or 90 raised to 0, then h raised to 0 or 90 raised to 1, h raised to 0 or 90 square, h raised to 0 or 90 cube. तो मैंने क्या किया, ये जो R90 है उसका 0 पावर 1 पावर 2 पावर 3 पावर उसको h के 0 पावर से मल्टीप्लाई किया मीन्स आई हैव टेक द कंपोजिशन. नाउ if I consider R90 raised to 4, then I will get the something back, so that's why I stop here. Now I consider again R90 raised to 0, R90 raised to 1, R90 square and R90 cube. But now I will multiply all this by why I stop here, because order of R90 is 4, we know, right? We have just compute. So if I consider R90 raised to 4, then I will get identity, and identity is what, R90 raised to 0 is identity, so I get the same element back. So I consider only 0 1 2 3 powers. Now I will multiply h raised to 1, h raised to 1, h raised to 1 and h raised to 1. No need to write 1, but just for the pattern I am writing this. So what I get, let us see. So this is what H and R90 both are element of D4. It's 0 power, means they are identity. So identity into identity is identity, and identity is what? It is R0. Now similarly here, H raised to 0, H raised to 0, H raised to 0, so it will be identity. So it is just R90. This is identity R90. Now this is identity into R90 square. So R90 square is R90, R90. R90 को 90 degree rotation दो, so it will be R180. So this will be R180. Similarly, this will be R270. Now H and R90 raised to 0, so this will be what? This is identity, and H raised to 1, so it is H. So this is my H. Now H R90 raised to 1. H1 R90 raised to 1 means H R90. So let us see what is H R90. So R90 into H. R90 into H. It is D dash. So this will be what? D dash. So this element is D dash. Now H R90 square. H R90 square. This is 1. So it is H R180. So H R180. H R180 is V. So this is my V. And H1 R90 cube. It will be H R270. R90 cube is what? R270. So H R270. H R270. It is, sorry, R270H. 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 So it is D. See here what we consider R90H. So R90 and H. First we consider first element, see whatever the first element from the column and second element from the row. So this is what D. So this is what D. So all these 8 elements are computed, and like this. So what I get? See. So actually this is what? R0, R90, R180, 270, H, V, D and D dash. H, V, D and D dash. So this is what? It is exactly my D4. Right? तो इससे हमें क्या पता चलता है कि मेरे पास जो वो 8 ऑब्जेक्ट्स थे, 4 रोटेशन 4 रिफ्लेक्शन, तो उसमें से मैंने क्या किया, एक रिफ्लेक्शन ले लिया और एक रोटेशन ले लिया. यहाँ पे मैंने H और R190 लिया, कोई जरूर नहीं H और R90 लो. यू कैन कंसिडर एनी रिफ्लेक्शन. इफ यू वांट D देन यू स्टार्ट विथ D, एंड एनी रोटेशन एक्सेप्ट ऑफ कोर्स आइडेंटिटी, right? Because it is a 0 degree rotation, but you accept identity, you consider any rotation, right? R90 or R270, not R180, not R180, any rotation which has order 4. So either you can start with R90 or R270. तो ये दोनों एलिमेंट्स है, मैंने ये सेट कंस्ट्रक्ट किया. तो ये सेट कैसा है? सी, इफ आई रिप्लेस, सो रिफ्लेक्शन रेस टू 0 and all possible powers of R90. See, R90's order is 4, so it has 4 power, 0, 1, 2, 3, 4 distinct power. If you consider any other power, then you will get one of the back. So I have considered all possible powers, and order of H is what? 2. So it has only 2 possible power, 0 power and 1 power. If you consider 2, 3, 4, 5, etc., then it will be either 0 or 1. So here this is what? It is a all possible powers of H and R90 and its product. Right? So then this gives me D4. So you can start with any reflection and any rotation which has order 4, right, and take its all possible powers and its product, then you will get D4. So now I want to just remove this H, D, R90, etc. also. So if I give the notation reflection by X and Y, rotation by Y, then this is what actually? It is X raised to I, Y raised to J, where this I is what? It is my reflection. So possible powers of X are what? 0 and 1. If you consider any other, then it will be either 0 or 1. So I varies from where? 0 and 1. And what about J? J varies from 0, 1, 2, 3. J varies from 0, 1, 2 up to 3. So 0, 1, 2, 3. And what is about X and Y? X is reflection, so its order is 2. So it is what? It is X square is equal to identity. And Y is what? It is a rotation, its order is 4. So what I have, Y raised to 4 is equal to identity. So now what I have this set, and now this is what? H is my X and R90 is my Y. So I got this set. So I have just replaced this notation by XY, and I listed this set with the property of XY. So this set will be what? You just replace X and Y by here H by X and R90 by Y. Then every element will be replaced in terms of XY. राइट तो मतलब वो जो हमारा स्क्वायर बनाया था उसकी फिगर मिली थी, उसका जो पोजीशन था वो इस डिनोट किया था इस नोटेशन से. सो ऑल दैट थिंग्स इज कन्वर्टेड इन टर्म्स ऑफ एक्स वाई. एंड व्हाट इज एक्स वाई? एक्स वाई इज रिफ्लेक्शन एंड वाई इज रोटेशन. नाउ यू फॉरगेट अबाउट द वर्ड रिफ्लेक्शन एंड रोटेशन ऑल्सो, राइट? यू कंसिडर two elements x and y so that x square gives me identity and y raised to 4 gives me identity. Means order of x is 2 and order of y is 4. तो मेरे पास कोई भी कोई ग्रुप है, तो कोई भी ग्रुप हो, we know various types of groups. So you consider any group and you just take one element. Any group means जिसमें से मिल रहा हो ऐसा ग्रुप. कि कोई मेरे पास ग्रुप है, उसमें से मुझे यदि एक 2 ऑर्डर का एलिमेंट मिल गया और 4 ऑर्डर का एलिमेंट मिल गया, देन विद दैट हेल्प ऑफ दैट 2 ऑर्डर एलिमेंट एंड 4 ऑर्डर एलिमेंट आई विल कंसिडर दिस सेट, राइट? आई विल कंसिडर दिस सेट. मैं ये सेट बनाऊंगा, राइट? और मिलते हैं हमें, हमारे पास यू कंसिडर सी स्टार विथ मल्टीप्लीकेशन. तो उसमें हर एक ऑर्डर का एलिमेंट है, फाइनाइट इनफाइनाइट. तो उसमें से आप एक 2 ऑर्डर का एलिमेंट ले लो और एक 4 ऑर्डर का एलिमेंट ले लो. सी इन सी स्टार विथ मल्टीप्लीकेशन, लेट मी जस्ट इल्यूस्ट्रेट. सी स्टार विथ मल्टीप्लीकेशन इज अ ग्रुप. तो इसमें 2 ऑर्डर का एलिमेंट है मेरे पास, यहाँ पे 2 ऑर्डर के एलिमेंट्स है यहाँ पे, राइट? सो यू कंसिडर लेट अल्फा बी द अल्फा बिलोंग्स टू सी स्टार एंड ऑर्डर ऑफ अल्फा इज 2. यू कंसिडर बीटा बिलोंग्स टू सी स्टार सच दैट ऑर्डर ऑफ बीटा इज 4. मिलेंगे आपको सी स्टार में. नाउ यू कंसिडर alpha raised to I, beta raised to j, and alpha square is identity and beta raised to 4 is identity. Identity here, identity is what? 1. And you consider I is equal to 0, 1 and j is equal to 0, 1, 2, 3, right? You consider this. Sorry, my mistake, एक गलती होगी. ये नहीं बनाएगा क्योंकि ये इसमें प्रॉब्लम क्या है कि ये अल्फा और बीटा वो कम्यूट हो जाएंगे, राइट? दे कम्यूट्स. लेकिन यहाँ पर क्या होता है कि दिस इज़ एक्चुअली माई नॉन अबेलियन ग्रुप. दैट वो अभी बाकी है डिस्कस करना, क्योंकि यहाँ पर एच और वी ये दोनों कम्यूट नहीं होंगे, राइट? ये दोनों कम्यूट नहीं होंगे. सो दिस विल नॉट वर्क. आई हैव टू स्टार्ट विथ सम नॉन अबेलियन ग्रुप. यू कैन स्टार्ट विथ फ्रॉम GL. यस, लेट मी गिव यू द एग्जैक्ट एग्जाम्पल. I have not enough space, but let me try. You consider GL 2R. You start, you consider A is equal to 0, 1, 1, 0. So this is what order of A will be 2. You can verify, right? You can verify. It is its order is 2. You consider B is equal to cos 2 pi by 4 minus sine 2 pi by 4 sine 2 pi by 4 and cos 2 pi by 4, and you can verify order of B will be 4. ये B का ऑर्डर है ना, आपको 4 मिलेगा. You just verify it. So A और B, I will consider this AB, A raised to I, B raised to J. A square will be identity matrix and B raised to 4 will be identity matrix, and this vary from this. So you will get 8 elements. और इसके जो 8 एलिमेंट्स, सो इट विल ऑल्सो फॉर्म द ग्रुप, राइट, वो भी ग्रुप बनाएगा, एंड दैट ग्रुप इज नॉन एज D4. दिस इज ऑल्सो D4. तो यहाँ पर मैंने किया क्या कि मैंने स्टार्ट किया था वो एक स्क्वायर से, उसकी सिमेट्री कलेक्ट की, फिर उस पर एक ऑपरेशन कंपोजिशन ऑफ फंक्शंस डिफाइन किया, और ये एक टेबल बनाया. फिर मुझे पता चला कि ये तो ग्रुप बन रहा है. फिर बाद में पता चला कि इसमें से कोई भी एक रिफ्लेक्शन ले लो और एक रोटेशन ले लो जिसका ऑर्डर 4 है, वो उसका आप इस तरह से प्रोडक्ट लेंगे, देन यू विल गेट द सेम थिंग. So why we consider reflection rotation like that? You consider any two element whose order is 2 and whose order is 4 from any non-abelian group, and you do this, then it will gives you group. So this group is D4. तो मतलब ये D4 एक्चुअली ओरिजिन तो वहाँ से ही है, रेक्टेंगल की सिमेट्री से, बट वी कैन रिप्लेस दैट ज्योमेट्रिकल आइडिया बाय दिस एब्स्ट्रैक्ट आइडिया, राइट. एंड व्हाई वी नीड दिस? Because see, here we are studying the symmetry of a rectangle. It has 4 sides, so it has 8 symmetry. So if you go for the pentagon, regular pentagon, then it has 5 sides, and if you find its symmetry, then it has 10 symmetry. We will see which that 10 symmetries are. तो उसको 10 symmetry मिलेगी, right? So you have this 10 notations like that. If you go for a polygon, regular polygon, having 20 sides, right, and if you collect all that symmetry, rotation, reflections, etc., then you will get 40 symmetry. In general, n gone, then you have 2n symmetries. So for 20, then you have 40 symmetry, then you have these 40 notations, and it is very difficult to calculate and handle it. But instead of that, you start with the symbols, you work with the symbol, forget about its geometrical positions, and we can deal with this. And if we need its geometrical meaning, then we can go from this abstract meaning to geometrical meaning also. But as far over this problem solving concern, we will deal with this abstract form. So I hope this is clear. So now we'll also discuss this GL2R or SL2R with DN in detail, but later on. So now let us in general we define DN. Okay, तो पहले मैं यहाँ पर हमने क्या किया कि एक मैंने रिफ्लेक्शन लिया, एक रोटेशन लिया, और उससे भी ये पूरा बन जाता है. मतलब it is something like generated by 2 element. We know generated by 1 element means it is a cyclic group. So DN is what? DN is a group which is generated by these 2 element. ये 2 एलिमेंट के सब पावर के कॉम्बिनेशंस ले लो, उससे ये सब एलिमेंट मिल रहे हैं. वहाँ साइक्लिक ग्रुप में क्या हो रहा था कि कोई एक एलिमेंट के पावर से मुझे ग्रुप का हर एक एलिमेंट मिल रहा था. यहाँ पर आई नीड 2 एलिमेंट्स, सो इट इज़ अ आई विल नॉट से इट इज़ अ साइक्लिक ग्रुप. साइक्लिक ग्रुप मीन्स व्हाट? ऑल द एलिमेंट्स आर ऑब्टेन्ड फ्रॉम द वेरियस पावर्स ऑफ अ सिंगल एलिमेंट. बट हियर I require 2 elements. So I will just say my D4 is generated by 2 elements, right? So number of generators पूछ ले कभी D4 के, definitely D4 is non-abelian, right? D4 is non-abelian. अच्छा देख लेते हैं अभी why it is non-abelian. तो कभी वो साइक्लिक तो हो ही नहीं सकता. Okay, so let us quickly see how it is non-abelian. So let us just compute this HV. HV will be what? You start with V and then H. So what you get? It is R180. And VH. You start with H and then you look at V column. H and V, यहाँ पर हमने क्या है V and H. See, okay, that's fine. These two commutes, HV and VH, are commuting. Okay, because they are reflections now. See, okay, you start with this R, H and R90. Because I want to show it is non-abelian, so I need only 2 elements which do not commute. So you just compute HR90. So R90 and then H, so it is D dash. Now R90 and H, so you start with H and R90, so it will be D. So D and D dash are not equal, so it is not abelian, right? So D4 is non-abelian group. ओके तो हमने अभी वो पेंटागन की बात की थी, रेगुलर पेंटागन. सो उसकी कितनी सिमेट्रीज मिलेंगी? लेट अस सी. दिस इज माय पेंटागन, राइट? से A, B, C, D and E. See, if you say this is R0 position, so 360 divided by 5 sides, so 5, right? So it is 72 into 5. So you give the 72 degree rotation in anti-clockwise or clockwise. Let us consider anti-clockwise, right? Then you will get R72, right? And it will be like this. 72 degrees, so it will be A, B, C, D and E. Now again you give R 72 degree, so let me say this is R 72. Again you give the 72 degree rotation in anti-clockwise direction, then you will have this one. A will be here, A will be there, A, B, C, D and anti-clockwise, right? So I give rotation like this. Sorry, A will not be here now. A will be here. A, B, C, D and E. So this is R72 plus 72, that is for 140. So let me give R144 notation, right? Again you give the 72 degree rotation to this position, and what I have, this one. So it is again add 72. It is R216 and the position will be like A, B, C, D and E. Again you give the 72 degree rotation, then you have this. So it will be again 72, so 288. So this position is 288, and the not this will be, we are giving anti-clockwise now. So in this way, anti-clockwise. So it is A, B, C, no, A, B, C, D and E, right? Again you give 72 degree rotation, then you will get this. A will be here. So you have 1, 2, 3, 4 and 5. So 5, right? So let me remove this. A, B, C, D, E, and by 70 degree rotation you have R0, R70, 72, R144, R6, 216, R72 ऐड करो तो 8, 8, 288 and R0 back. Now see, let me draw the figure. In clear way, then this is A, B, C, D and E. Then you draw a line like this, passing through a vertex and perpendicular to opposite side, intersecting at the midpoint of the opposite side. Then you just reflect with respect to this axis. Then you have E and D here, B and C here, A as it is. So let me say it is FA. Reflection about the axis passing through vertex A. Similarly, you have another symmetry is FB. Another symmetry is FC. Another symmetry is FD. and another symmetry is FE. So you have this are symmetry, these are rotations. So if you look at hexagon, regular polygon with 6 sides, A, B, C, D, E, F, then 360 by 6, that is 60. So on 60 degree rotation, you will get the symmetry. So this position is say R0, then R0, then R60, R120, R180, R60. So 0, 240, and R300, and R360, that is R0. 1, 2, 3, 4, 5, 6. 6 rotations. And you consider this. In the case of even degree, even sides of a polygon, you have two opposite vertices. So now you take the reflection about this A and D. So EF and BC. So that will be a symmetry. So let me give that symmetry by F, AD, A and D. Then CF, then BE, then what? ADCFBE. Okay, now so I have that 3 symmetries. Now you consider opposite sides like this. Then this C and D will interchange, B and E will interchange, and A and F will interchange. So let me say opposite sides. So F1. So this is line 1. Now similarly you have this is line 2, F2, and say this is line 3. So F3, right? So this 3, 3, 6. So these 6 are reflection, these 6 are rotations. So if you consider any n gone, then you have n rotations and n reflections, total 2n elements, and this will forms the group with the composition of functions, and that group is known as Dn, dihedral group, right? It will be non-abelian for n greater than or equal to 3. Why for n equal to 1 and 2 it is abelian, we will see. It is a very trivial thing, but for n greater than or equal to 3 it will be non-abelian. But we want to make it abstract, so we will not go with these figures like that. So if you want to define dihedral group of order n, then what we need? One reflection, one rotation, और वो n गॉन पे है. See यहाँ पर 6 है, here n is equal to 6. So this will be a group, right? And notation for this is it is what? D6. तो D6 को मैं ये जो R0 R60 ये नोटेशन से रिमूव करना है. So I will take X whose order is what? 2. Order of X is 2, that is X is reflection, and one rotation, say Y, and order of Y is what? Its order is 6. Then I will consider X and Y like this, and I will consider X raised to I, Y raised to J, right? And here order of X is 2, so X square is identity, Y raised to 6 will be identity, and I varies from 0, 1, and J varies from 0, 1, 2, 3, 4 and 5. So this will be forms a group, and it will be exactly this one. We are just changing the notation, right, to avoid this geometrical calculations. So this will be what it is, your D6. So in general we can define Dn, right? Okay. और एक दूसरी चीज़ कि यहाँ पर मेरे ये जो x और y के बीच में कैसा रिलेशन है. See, if you see, let us observe first here only, then we move for the general case. देखो, this is what R0, this is R60. तो ये R20 क्या है? R0, R60, R120, R180, R240 and R300. See, this is R0, this is R60. R120 is what? It is R60 square, right? 60 degree rotation 2 times. R180 is what? R60 cube, 60 degree rotation 3 times. Similarly, this will be R60 raised to 4 and this is R60 raised to 5. So if you concentrate only on this portion, then this is nothing but it is a group generated by R60. So this portion is what? It is a cyclic group, right? Cyclic group of order 6. It behaves like this and in fact it is this. तो ये जो इसमें से मैं कोई भी दो एलिमेंट ले लूंगा, मतलब फॉरगेट अबाउट R0. नाउ यू से इट इज आइडेंटिटी एंड नाउ इट इज से a, then it is a square, a cube, a raised to 4 and a raised to 5, right? Then if you consider any two elements from this group, then they will commute because it is a cyclic group, so it is abelian. So any two elements from this portion in D6 will commute. But if you say and what about this? What about this? इसमें से दो एलिमेंट कम्यूट नहीं होंगे. And what about one element from here and one element from here? तो you consider this R60 into FB. तो ये भी इसी में से कोई एलिमेंट रहेगा. So R60 and FB will not be equal to might not be equal to FBE R60. We have to evaluate it and we will see which elements commute, which elements do not commute. So in this way, dn is what? It is non-abelian for n greater than or equal to 2. So let us first of all we define dn. अच्छा, तो ये जो मैंने बात की कि ये एलिमेंट तो एक दूसरे से कम्यूट हो जाएंगे, लेकिन एक मैंने एलिमेंट यहाँ से लिया और एक एलिमेंट यहाँ से लिया, राइट? फिर दो एलिमेंट मैंने यहाँ से लिया, तो उसके बीच कैसा रिलेशन है? सो दैट इज कॉल्ड कॉम्यूटेशन लॉ. दैट इज कॉल्ड कॉम्यूटेशन लॉ. सी अबेलियन ग्रुप में क्या होता है? अबेलियन ग्रुप में ए बी इक्वल टू बी ए, तो वो भी एक लॉ है कि ए बी को आपको उसकी साइड चेंज करनी है, ए लेफ्ट बी राइट. देन इफ यू चेंज द साइड देन यू आर अलाउड. सो दैट इज अ लॉ to changing the side of the element in the abelian group. So that is a law to commutation. But यहाँ पर मतलब वो हम साइड चेंज कर दे तो एलिमेंट सेम रहे, ऐसा जरूरी नहीं नॉन अबेलियन ग्रुप में. तो मतलब मुझे सेम रखना है, तो कौन से लॉ से मैं उसको चेंज करूँ तो वो सेम रहता है, राइट? सो विल सी, दैट इज कॉल्ड कम्यूटेशन लॉ. तो ये हमारे डीएन में हमारे पास एक इसका कम्यूटेशन लॉ है कि यदि आपको एलिमेंट को साइड चेंज करनी है, देन इट मे नॉट बी रिमेन सेम, बट इफ यू चेंज इन सम वे, by some law, then you have that two quantities are equal. So let us see. Now let me remove this also. Okay, fine. So the abstract definition of Dn. Of Dn. So Dn is equal to what? It is like x raised to I, y raised to j, where x square is identity, y raised to n is identity, and where I varies from 0, 1 and j varies from 0, 1 to up to n minus 1. तो इसके जो एलिमेंट्स है वो कैसे दिखेंगे? लेट मी लिस्ट. आई वॉन्ट टू राइट समथिंग हियर, बट आई विल राइट लेटर ऑन. ये i की वैल्यू क्या करनी है? मुझे 0 और 1 लेनी है. तो हियर first let me write here. Here x is called reflection and y is called rotation, right? Now x will be the member of Dn. It is a reflection, but we denote that reflection by symbol x. So x raised to 0 will be definitely identity, and similarly y raised to 0, because y is also y is rotation element of Dn, so its 0 power will gives me the identity. So when I consider the value of I is 0, that is x raised to 0, so it gives me identity, right? And now you fix I is 0, and let me write x raised to 0, y raised to 0, x raised to 0, y1, x0, y2, and like that x0, y raised to, because j varies from up to n minus 1. Then I is 1, so x1, y raised to 0, x1, y raised to 1, x1, y square, and so on, x1, y raised to n minus 1. So I have this side. Okay, now x raised to 0, y raised to 0, identity into identity. So this is what identity. So let me write this way, it is identity. Now x raised to 0 is identity, so no need to write x raised to 0, x raised to 0. Now x raised to 1, so it is x, so no need to write this 1 also, right? So your Dn will be look like this, your Dn will look like this. You have x and y. Let me give notation here. We are constructing this set with the help of two elements x and y, so x comma y, where this set contains, you start with E, and this is my reflection, and this is my rotation. Then the powers of rotation, that is y raised to 1 means what it is, y square, y cube up to yn minus 1, and you multiply all these elements by reflection, that is x. You multiply E by x, then it is x, y it is y0. E by x, then x, then y by x, then xy, y square by x, then xy square, and so on, right? So your Dn is look like this. So let me rewrite. So it will be identity y square, y cube up to y raised to n minus 1, and x, xy, xy square, xy cube, and so on, xy raised to n minus 1. So I have n elements plus n elements, so total number of elements in Dn is 2n. Okay, now how the elements behave, आप यहाँ से कोई भी दो एलिमेंट ले लेंगे, देन दे विल कम्यूट, बट एक एलिमेंट आपका x है और एक यहाँ से कोई है, मतलब ये कोई एलिमेंट्स आ गए, तो उसको कंप्यूट कैसे करेंगे? सो फॉर दैट वी हैव दिस लॉ, वाई एक्स इज इक्वल टू एक्स वाई इनवर्स. एक्स और वाई, ये एक्स और वाई ये दोनों एलिमेंट से जनरेट हो रहे, दैट इज देयर आर बेसिस एलिमेंट इन सम सेंस. तो वो दोनों का बिहेवियर कैसा है? वाई एक्स इज नॉट इक्वल टू एक्स वाई इन जनरल, राइट. पर ये जो मेरा वाई एक्स है, वाई को मुझे अभी एक्स की लेफ्ट साइड में उसको राइट साइड में ले जाना है, देन आई कांट have equality here. If I consider here -1 power, then I have equality. So this is what? This is a commutation law. How x and y commute, but they will commute in this way, not in that AB equal to BA, right? So this is called commutation law. So if we apply this law, then we can have commutation between any two elements. We'll see how we can obtain computation for between any two elements with the help of this thing, right? So I am adding this condition here. Okay, तो ये मेरा dn हो गया, yx is equal to xy inverse. So here I have listed all these elements, and let me write here where yx is equal to xy inverse outside this bracket. My purpose is to show here is what I have two n elements where n elements are of this type and n elements are of this type, and they follow this rule. Okay, here x is called rotation and y is called x is called a reflection and y is called rotation. So this is what my dn. तो मतलब ये जो dn है, okay, and it is non-abelian. Let us see how it is non-abelian. See, यहाँ पर y का ऑर्डर क्या है? ऑर्डर ऑफ y इज व्हाट? इट इज n. और मेरे पास यहाँ पे रूल क्या हो रहा है? yx इज इक्वल टू एक्स वाई इनवर्स इस ग्रुप में, राइट? सी, नाउ सपोज ऑर्डर ऑफ y is n and n is greater than or equal to 3. So implies y inverse definitely equal to y. उसका इन्वर्स y नहीं मिलेगा, वो सेल्फ इन्वर्स नहीं होगा. सेल्फ इन्वर्स कौन होते हैं? आइडेंटिटी. तो आइडेंटिटी का ऑर्डर तो 1 होता है, और यहाँ पर y का ऑर्डर n है और n 3 से बड़ा है. और सेल्फ इन्वर्स और 2 ऑर्डर का एलिमेंट है, वो सेल्फ इन्वर्स होता है. तो y का ऑर्डर तो 3 से बड़ा है. So y is not self inverse. So y inverse is not equal to y. So this is not equal to x into y. Y inverse is not y, right? So yx is not equal to xy if n is greater than or equal to 3. तो मतलब क्या हुआ? So therefore, okay. So dn is non-abelian. मुझे दो एलिमेंट्स मिल गए, x and y. You consider one x and this from here y, which will not commute if n is greater than or equal to 3. For n and 2. What about 1 and 2? Okay, so what is the time? Let me see. Okay, what about 1 and 2? d1. d1 में क्या रहेगा? n is equal to 1. So 1 minus 1 0. So j is 0. j is 0. तो क्या रहेगा? x raised to I, y raised to j. x square is identity and y raised to 1 is identity. y भी मेरा आइडेंटिटी है, तो मतलब ये क्या हो गया? ये y ही हो गया. सो d1 वैसे जो है, देखिए ऑर्डर ऑफ d1 शुड बी व्हाट? 2 into 1, दैट इज 2. एंड हियर आई हैव टू कंसिडर i equal to 0 1 and j is equal to 0 up to n minus 1, that is 1 minus 1, that is 0. So I have this thing. So if I try to list elements, then it is what? You fix x raised to 0, y raised to 0, and x raised to 1, x raised to x raised to 0, y raised to the possible value of j is only 0, so 0. Then you fix I is 1 and all possible value of y, so it is 0. So this will be what? It will be, this is identity and this is just x. So d1 is a group having only 2 elements, so it will be what? It is z2, cyclic group. 2 order का group, prime order must be cyclic, so it will be z2, right? And what will be d2? So order of d2 will be what? Order of d2 will be 2 into 2, that is 4. 4 means 2 square, prime is square, so it must be abelian. तो वो ये मुझे abelian मिलेगा. It will not be cyclic. देख लेते हैं कैसा मिल रहा है. Okay, we'll see in next lecture. It is 2 square, so it is abelian. So d1 and d2 are abelian, but for dn, here we have proved dn is नॉन अबेलियन फॉर n ग्रेटर देन और इक्वल टू 3। तो मतलब वो ग्रुप एलिमेंट कैसे है, कितने एलिमेंट है और उसका नेचर अबेलियन है कि नहीं है, दैट कैन बी नाउ क्लियर फॉर dn for all n belongs to n. Okay, so we stop this lecture here, and in next lecture we'll discuss the properties of dn. तो अभी तो इस लेक्चर में हमने क्या किया, सिर्फ dn का बॉर्न ही हुआ है कि dn क्या है, वो सिमेट्री से ले आए, फिर उसको एब्स्ट्रैक्ट किया dn को. नाउ विल प्ले विद द dn कि उसमें हमें काम करना है तो उसकी प्रॉपर्टीज़ क्या है, कितने ऑर्डर के कितने एलिमेंट है, कौन सा एलिमेंट किस एलिमेंट के साथ कैसे बिहेव कर रहा है, उसके सब ग्रुप कितने हैं, उसमें से साइक्लिक कितने हैं, राइट. सो ऑल दिस थिंग वी विल डिस्कस इन नेक्स्ट लेक्चर. सो थैंक यू. वी स्टॉप दिस लेक्चर हियर.